Okay, now we are back in terms of talking about LRU cache. Sorry for the front half, I actually was not recording because I actually clicked start virtual camera. I actually should click start recording. And okay, you can see it only used like 2% of my CPU for OBS Studio. That's really good. Okay, so when we do self.head.next equals to node, what does it do? Okay, it points to the current node that we're trying to insert. So self.head.next.previous, it actually points the first node to our current node. Is that clear? Okay, that's clear. Okay, so at the end of the result, right, let's do at the start what is going on at the start. We do self.head equals to the, I'll just do bracket first node. And it points back to the self.head. Okay, at the end, what happens? Can you imagine what happens? Okay, when we insert the node, it should look like this. That's what we want to achieve, right? I put comments that it looks even nicer than ChatGPT, right? So this is very valuable. Okay, let's run through this. Node dot previous, we point it to self dot head. So this gives us the arrow over here. Okay, this arrow over here, and you can see in this diagram below how many arrows we need to add. We need to add 4 more arrows. Okay, so there's 4 lines. So node dot previous equals to self dot head. This gives us this arrow. Node points to self dot head. Okay, which is over here below. Next, node dot next equals to self dot head dot next. Okay, which points our node to self dot head dot next, gives us basically first node. Okay, I'm just gonna delete it because now we know. Okay, self dot head dot next dot previous equals to current node. So basically it points the first node to the node. Alright, so it's this relationship over here. Okay, so self.head.next points to the node, this one. Okay, so node.next actually points to this one. So you see in this line, we actually implemented this add function. So this is a very important function for the LRU cache. And what does it do? It allows us to add it to our doubly linked list. And we will use the remove function to remove a node from this doubly linked list that we are maintaining over here with the help of self.head and self.tail when we are putting new nodes into our LRU cache. Right, so I will handle that later. But for now, just add function will do. Okay? I'm just gonna add a comment here. Okay? Next, I need to do define, remove, self node. So this will help me remove it. So how will it do? So I will just add this example again. Self.head points to this, okay, and it will get me this, right? Hopefully that is clearer for both myself and for you watching. Previous equals to node.previous. Next equals to node.next. Basically node.previous we will get self.head actually. Node.next we will get the first node. In this case, but normally when we are removing, we are removing from the tail. Okay, so we are getting second last node, and then it points to the self.tail. Because normally when we are head is pointing to the first, when we are removing from the tail. So at the end, can you imagine what we will be getting in the end? We will be removing the node, which will point to this. Okay, so instead of node.previous, right, I will be getting second last node. So previous will point to second last node. In fact, I'm just going to rename this later into second last node. Next, we will get node.next, which is actually self.tail in this case. Technically, this method will work for any part of the code, will work for any node in our doubly linked list. But in this example, I'm just going to illustrate this example with the help of removing the node from the tail. And that's why I'm using second last node. So we are doing previous dot next is equals to next. So what does it do? Right? Let's just pause and see what does it do. We are pointing second last node to self.tail in this case. Right? Essentially what it does is it removes, or rather it points, instead of the arrow pointing here, which is this arrow I highlighted, instead of pointing to the node, it actually ignores this node in the middle, and it actually just, okay, I mean just imagine this highlighted part is removed. So instead of second last node pointing to node, second last node is now pointing to the self.tail, which technically it jumps one node, right? Except that in this code, it could work for any nodes within the doubly linked list or the LRU cache. Next, I'm doing next dot previous equals to previous. In this case, let's just apply this next dot previous. Self basically is pointing, okay, it's just self.tail is pointing back. What is it pointing back on? It's pointing back on previous. And what is previous? Previous is our second last node. Okay? So what does it do at the end? It basically loses the reference of this node. It basically loses the reference of this node. Technically, in this case, node will still be pointing at self.tail, and node will still be pointing at the second last node. Technically, it will be pointing. But at the end of this method, the reference of node, it will be no longer stored in the memory. And since we are just accessing our doubly linked list via self.tail, we will only be able to retrieve the second last node, and second last node will only be able to retrieve self.tail in that case, right? We can also add one more thing. We can also do node.next equals to none, node.previous equals to none, right? Which will result in node being so-called being stuck in the void with no one to point to. We can also do this, but it's sort of not necessary because the reference will just be lost in this case. Okay? So technically 4 lines is enough, but I'm just illustrating it for those who are encountering this problem for the first time. Okay, next we want to implement the get key function. If key in self.cache, we do node.self.cache equals to key. Okay, this is very simple. Why? Because the cache is already defined here and we are just getting it. So if the key is in cache, we are getting the node. Okay, we are calling it because we want to remove and add. I guess this makes it simple because when we are removing it and we are adding it to the front. Now I don't really, there is a better way, but just for simplicity, we will just remove it and add it because it's an O1 operation, because it's a doubly linked list. So technically we do not need to do it if we detect the node to be in the front, right? I'll just add it first. Self.remove node, self.add node, and then I will just return node.value. You see, now there is no type hint, but ideally we will just add type hints later in this case. And if it's not found, I will just return -1. Okay, but let's look at this solution. I already mentioned that this is not required, as in this is not always required. If when is it not required? Let's show an example. If the self.head is pointing to this key value pair of 1:1, and then it's pointing to this node of key value pair 2:2, and then it's pointing to self.tail. Okay, in this case, if you are getting the first node in the list, you do not actually need to remove it and add. You do not actually need to do it. But because it's an O1 operation, it's so efficient, you could do it without increasing the runtime complexity of it by a significant bit. It will not change by a significant bit. But in a case where you want to be very strict about this, we can do this check. If self.head.next not equals to node, not equals to the value, okay, if it's not, then we want to remove it and add it again. Now let's just think about it, whether if there is, this will call this method if it's not the front. If self.head.next.value is not equal to node.value, then it will remove it and add it again. Is that what we want? Let's look at it. For example, if the state of the LRU cache is in this format, it's pointing to 1, it's pointing to 2, and then tail. And then from self.head, we are getting 2. Sorry, we are getting 1 first. So we'll do self.head.next, which will give us this, .value, which will give us number 1. So if we are accessing by the key actually, yeah, if the key is not equals to key, then we will remove it. Because in this case, there will only be one unique key per node. When we put it, you can see later, when you put it, if the key is in the cache, we just want to remove it straight away. So there will, no nodes will be, it will not be in this case, where we are pointing 2 to 3. This will not exist, right? Because if the key is in self.cache, we will just remove it. We will just remove, for example, the old reference, and then we will add the new node inside. Okay, so this is the understanding of how it works. So this actually can be kept here. So if self.head.next.key is not equals to key, then I want to remove it and add it, which basically saying that if it's not at the front, just write it, if the node which contains the key is not at the front, then we make it front, right? We make it to the front. Okay, so I'll just remove this as well. Okay, now get is done already. Let's implement put function. If key in self.cache, we do self.remove self.cache.key bracket key, that's what I mean. So when we get self.cache.key, it actually returns us the node, and now we are removing it because the key is already inside the cache. And what we will do, let me just look at what we will do. You will just add it to the front. Okay, our add function just adds it to the front. You can see. self.head.next, it basically, okay, you can see self.head, it starts here. At the end of the function, it puts our self.head, it points to the node. So what it does, it edits to the front. Self.head is pointing to the front. Okay. This is a rather lengthy tutorial. We are already at 15-minute mark and I kind of started halfway. Okay. Remove self.cache.key. And node will be equals to node key value. Okay. And of course, the node class, right, it jumps to the class that we defined earlier. Okay, so we just basically create a key value pair, and then self.cache dot key equals to node self dot add node. Okay, so basically we add it to the front, the head of our doubly linked list. Add to our dictionary. Basically, the double linked list tracks the most recently used. Okay, and the last part, if the length of self.cache is more than the capacity, what happens? You just think about it, what happens without looking at the answer. Let's look at this. Okay, if our capacity, if we are given this and our capacity is equals to 2, and we are doing, and the current state of our list is this, and we are doing a put. Let's say we are doing a put 3, 3. A key value of 3 is to 3. What happens? Right? Because we know that in the LRU cache, we are just storing the most recently used node which is in the front. We want to remove the node at the end. So instead of pointing to 2, 2, our final result will be removing this, and then we want to put our 3, 3 over here. As in, no, that is a mistake. Do you realize that? It's not that. We want to remove from the back, and we want to add it to the front. That will be our final result. Okay, so I would want to illustrate this in a sense that it is not actually directly like that, right? It actually goes to this step where we are pointing this, and then here we check for the capacity, and then at this step we check for the capacity. If it's more than 2, then we want to remove the last node, because in this put operation we add one node and it has a chance of exceeding it by one node, so we'll just remove the one extra node. So it's a very efficient algorithm because we are using doubly linked list. All the inserts and remove operation is all in O1 time, just that there will be this initial step of we need to write this class node, and you want to define the constructor underscore underscore init self key value. So we want to self dot key, self dot value, and then previous and next for our doubly linked list node. So if it's more than capacity, what happens? Okay, of course, what we want to do, we want to get the least recently used. We can call it LRU dot tail dot previous, right? This will give us the least recently used, right? Basically, it will give us 2, node 2. Okay, and when we have node 2, what happens? We can just do self dot remove our node. And what does it do? Let me see. It will get the node, and then it will remove it. And why is it so simple? We need to look at this. Why is it so simple? Because instead of just being pointing in one direction, because of the doubly linked list effect, it is actually pointing in both directions in this case. And when we were to remove this LRU, right now our LRU refers to node 2. When we are doing the remove function, we actually already have the reference of the previous node and the following node. And that's really the key in this algorithm. Because we can just take any single node in the list. We can do self.hit.next, and we can take this, and then we can just throw this node into this remove function, and it will be able to just remove the middle node, resulting in self.hit 3 points to 2 points to self.tail. Right? So that is the powerful, or rather the advantage of having a doubly linked list, because it maintains the references. So self.remove list recently used cache, and then we want to delete this self.cache from, we want to delete the LRU from our cache. Okay? That will be the breakdown of this method. So I know I implemented this. It took about 20. Now we are at 22 minutes. As I was talking over through. So this will be the same amount of time that we will do it in the interview, plus the initialization method of node, of init, of self. Right? As I'm talking through, it probably takes about 25 minutes. Okay, so let's just take this, and I will paste it into my LeetCode. I will close this. I will reset this. You can see I've been trying this. Okay, let's just take this and paste it over, and we'll run it. So for the test case, it passes, and I'll just submit it. Okay, and I'll label this as DeepSeek R1. Okay. Okay, you actually should be able to just save it. And I'll just go back. DeepSeek R1 is over here. Okay. Let's review this. We declare a doubly linked list node. We init it with capacity and cache. So we are already given a capacity. So we just need to remember that we need to declare this cache for O1 access. O1 get. And for the head, this is actually just a dummy node. We want to point to the most recently used, and that makes sense, right? Because the head, normally at your head, we want to have the most recently used. Okay. And for add, we want to do node.previous. We just want to point this node to self.head, and for the node.next, we want to point it to the first node, which will be self.head.next. Okay. Now we are just adding the pointer for the node. As of right now, the doubly linked list does not know about this node yet, but the node knows about the doubly linked list. Okay, so we want to help our doubly linked list know about this node. So what they do is self.head.next equals to node. And this is the very important code. And self.head.next.previous points to node. It will be this node, our first node, pointing back to our node. So actually, I will just put it at the front because it helps me remember better. Okay, and remove, we will just get the second last node, and for next, not next, it will just get the tail. In this case, actually, we are sort of able to just hard code it to be the self.tail. It actually works that way as well. But we need to keep it this way. Why do we need to keep it this way? Okay. For example, the current state, and you will know why doubly linked list is so useful. For example, our state of doubly linked list is in this. 312. But now we are adding, now we are getting a new put operation. I'm telling you, key 1 gives us 5. So what happens? What happens? Okay. When we are doing a put, if key is inside, we want to remove it. You see this? We want to remove cache.key. So what it does? What do we do? Okay, in our method, it will call remove self.cache 1. Which will makes us remove the node 1. Okay? So what it does, it basically removes this. Right? It's just that my example over here is just an example to help us trace the code, but this method actually helps us to remove node from any point in the list as long as we have the reference of the node, a doubly linked node. Okay? And what happens after that is it will add 1 to 5 to the front. Okay? As we can see here, self.add node, it added to the head of our doubly linked list. Okay, I'll just run it. Line 82. So now I'm just going to debug it. Okay, you know what? I'm still debugging, but I'm going to just record this. Okay, so what happens? Our hit dot, okay, basically hit dot key, it gives us nothing. So I will just do dot next dot key dot next dot value. For tail, I will just do dot previous dot value. I will just do okay. So what it does, it gives us 3, 1. Okay, and what are we putting inside this function? Okay, what is the value that we are putting in? Okay, key value. Let me just get. Okay. Actually, this is where we know that logging statements are very good in terms of the method. So we have put 3 at the front. See, here's the thing about this cache. For this cache, we could improve the dictionary so that okay, we need to add a toString method to this node. So how do we add the toString method? Let's define string. Right? We want to return node. Okay, node. I'll just put it simple for now. Node plus string key. I'll just do string key plus colon string value. But we can't do value, we need to do self.value plus comma. Okay, I just need to add self.key in front. Just add a plus over here. Okay, and with this we will be able to print out our node. It's very important for debugging purposes. Okay, let me just add it here. N equals to node 2. Let's just save it to the power of 2 for let's print N. Okay, let's see. Node 2 for, okay. Okay, when we run this, we should be able to get the node object. Okay, for some reason it's not printing. Let me just add node 2 4. Yeah, it actually gives us node 2 4. Okay. Okay, perhaps this is just getting the reference to the node. Okay, let's run through the test case. Capacity 2, we are putting 1. Okay, let's run through this test case here. So we have a capacity of 2. Basically, we just stores it as 2. Just do cap equals to 2. We are putting 1 1 into the node. That's all. And then we are putting 2 2 into the node. And then we are getting 1. Okay, so there's no change. Now we are putting, let me just put it here, we are putting 3 3 inside. So we are actually putting 3 3 inside. But it's actually not at the back. Okay, it's at the front. And then we are removing 2 2. Okay, so it gets this. And we are getting 2 2. It just returns -1. And now I'm putting 4 4. So I do not have 1 1 anymore. And then now when I'm getting negative, I'm getting 1, it will just be -1 again. I'm getting 3, it will return 3. And when I get 4, it will return 4. Okay? So which part does it not make sense? Okay, so what we have to do here is we just take the key. If key is in self.cache, then we want to delete the key. Otherwise, it's already not inside. Maybe a quick way to fix it. Okay, why am I getting a 2 here? Okay. Running through again, put, get, put, and we are getting a 1. So 1 is at the front. We are putting a 3 3. So 3 3 is at the front. We have removed 2. We are getting 2. So we are getting, okay, yeah, so this -1 should not be here. It seems like my code changed it. Okay, I need to print LRU.key. So the state of our dictionary, we have 1, 2, 3 in our dictionary. So we have to remove LRU key is 1. So because this is a put operation, we are putting 3 inside. So you can see our working here, we are putting 3 inside. We have to delete this 3 from our cache. But only want to remove the least recently used. Okay, what I want to do is I want to do pointer 1 is equals to self.head, while p1 want to loop to the end. Pre1 key, I'm going to do an f string. P1 dot key, P1 dot value equals to and equals, and then print. Good, debugging is good because it helps us to understand the code better. Non-object has no attribute val. Okay. It's not val because it's value, okay? Self.head.next. Now, it seems like we have gotten an infinite loop error. Okay, so I've successfully debugged that error. It actually turns out that there is actually not much error, but I managed to add a new class, as in a new method here that helps me to print and debug it. Okay, so it seems it's fine. It's just that when we are trying to get 2 over here, it will just get us -1, which is over here. We want to print s.get2, which will get us -1. When we do 1 here, it will give us 1. But when we put 3, it evicts key 2. Yeah. Now let's just do this, it makes it more readable. Yeah, when we get 2, it will just give us -1, which is the test case that was failing just now. And hope it helps. If you want to debug your code, you can always just do REPR, which stands for the Python built-in class for representation, so that you can just print it directly, because even though they don't tell us how to, they don't require us to implement it, we can always implement it so that it works. So that is the end of this video. Hope you learned something. Until the next one.